Lesson 6.8, Counting Principle. A tree diagram is one way to count the number of possibilities. It uses branches to list choices. Again, you don't need to write this down, and you don't need to write this. It uses branching to list choices. Counting principle uses multiplication to find the number of ways two or more events can occur. In example 1, let's make a tree diagram. At a picnic lunch, you choose one sandwich and one salad. The choices include the following: veggie burger, hamburger, tuna sandwich, garden salad, and fruit salad. How many different picnic lunches are possible? To figure this out, we need to count the number of possible picnic lunches you can make a tree diagram. So list the sandwiches first. And you can abbreviate these, okay, if you need to. Then from there, make branches to list the salads that you can get with each sandwich, garden and fruit. So each type of sandwich gets a garden and a fruit salad. Again, abbreviated G and F. That means you can get a veggie burger and garden salad, a veggie burger and fruit salad, a hamburger and garden salad, or a hamburger and fruit salad, or a tuna sandwich and garden salad, or a tuna sandwich and fruit salad. Again, you don't need to actually do this part necessarily. You just actually want to count the very end of the tree diagram. 1, 2, 3, 4, 5, 6. There are 6 different picnic lunches possible. I did have to move the answer up to the top. Suppose for checkpoint 1, and for each picnic lunch from example 1, you also get to choose one fruit. The choices include the following: apple, banana, orange, and grapefruit. So, we could just go back here and make our choices. I believe we had 4 different choices: apple, banana, orange, grapefruit. So each part gets an apple, an orange, a banana, or grapefruit. Apple, orange, banana, grapefruit. And you do this for each one. Please figure out how many possible picnic lunches choices there are. Pause the video and finish the tree diagram. There are 24 possible picnic lunches choices now. The counting principle is just a different way of doing the exact same thing, but you don't have to make the tree diagram. If one event occurs n ways, and for each of these ways a second event can occur n ways, then the number of ways that the 2 events can occur is m times n. What this means is when you pick the sandwich, there were 3 choices. When you picked the salad, there were 2 choices. When you picked the fruit, there were 4 choices. Multiply these together, 6 times 4, there's your 24. In example 2, you roll a number cube and randomly draw a marble from a bag. There is one marble for each of the following colors: red, blue, green, and yellow. Use the counting principle to find the number of different outcomes that are possible. Well, you roll a number cube. How many choices do you have in a number cube? Number cube is usually 6-sided, so you have 6 choices. The marbles, there is a 1, 2, 3, 4 choices, 4 colors. So 6 times 4, 24 possible outcomes. Again, you could make a tree diagram. You take 1, 2, 3, 4, 5, 6, and from there you do your red, blue, green, yellow, but you're still going to get the same possibilities of 24. Try number 2, use the counting principle to find the number of different outcomes if you roll a number cube, randomly draw a marble from a bag, and flip a coin. There is one marble for each of the following colors: red, blue, and yellow. Pause the video and try number 2 yourself. The number cube is 6. A marble has 3 colors, and a coin only has 2 sides. So 36 is your answer. For example 3, let's find a probability. The access code for a car's security system consists of 4 digits. You randomly enter 4 digits. What's the probability that you choose the correct code? We use this all the time. When you lock your cell phone so nobody can access it, or the garage door opener keypad. We use these types of codes all the time, and we need to figure out what's the probability that somebody's going to guess your code. First, let's find the number of different codes. So we use the counting principle. It's 4 digits, and the digits can repeat. Now be careful, because you have 0 through 9 as your digits, which means there are 10 choices for each digit. Multiply that together, it's 10,000. Now we have to find the probability. Okay, so the first thing we needed to do was use the counting principle. Now we need to find the probability. Remember, probability is always going to be some sort of fraction or ratio. Well, how many codes are actually going to let you into the security system? 1, right? 1 out of 10,000. That's the probability that you choose the correct code. Looking at checkpoint 3, your computer password has 2 lowercase letters followed by 6 digits. Your friend randomly chooses 2 lowercase letters and 6 digits, so your friend is trying to guess your password. Use a calculator to find the probability that your friend chooses your password. They want you to use a calculator because it is the possibility that he's going to find the password is pretty low. So let's do the counting principle, okay? First thing we need to figure out is our password. How many choices do we have? 2 lowercase letters. And by the way, please pause the video first so you can try this yourself and you can see if you get the right answer. Your computer password has 2 lowercase letters. There are 26 letters in the alphabet. So 2 lowercase letters, 6 digits. So, oops, there is 10 digits to choose from. It looks like you can repeat the digits. If you can't repeat, then it's going to be a little different. Here's where you have to use a calculator. Multiply those together. Now, what's the choice that they choose your password? 1 out of, what is that? 676 million. 1 out of 676 million. So, pretty slim that they're going to choose your exact password.